representing data. This is the examination question from June 2009. It was question 4. Apparently, the researcher in this example has measured the foot lengths of a random sample of 120 10-year-old children, and the lengths in centimetres of their feet are given in this table here. Number of children is also given. It asks us to use interpolation to estimate the median. Now, if you remember, when we're doing the median, we work out n over 2. They've told us it's 120 children, so divide that by 2, it's 60. Now, it's grouped data, remember, so we're not going to round it, we're going to leave it as it is there. Let's see, we've got a cumulative frequency of 5, 58, don't think I'm going to have to go too much further, 87. I think I'll stop there because I'm after item number 60, so I know it's in this interval here, 17 to 19. So I draw a little picture of this interval, 17 to 19. The cumulative frequency at the beginning was 58, and at the end it was 87, and we're after number 60, so it's going to be near the beginning there. If you remember the formula, it's the lower class boundary plus the frequency that we're looking for. Well, if that's number 60, and there was 58 up to the beginning of the interval, we want 2 of them. 2 out of how many? Well, 58 up to 87, that's 29 values. So we want 2 out of those 29, multiply it by the class width, which is 2. Remember, we work that second part out first. And if you grab your calculator and work that out, I think that works out to be 17.1. That's the 3 significant figures. The next part of the question asks us to calculate estimates for the mean and standard deviation of the data. Now, you'll need a lot more columns here at the side. We'll need a midpoint column, and we'll need a frequency times the midpoint column, and then an FM squared, remembering to square the midpoint first, then times by the frequency. I'll work out the midpoints with you, and then I'll just give you the totals for these and check that you can get those yourself. So the midpoints, I think, are 11, 14.5, 18, 20, 22, and 24. So for the first column, you'll be doing frequency, 5, times the midpoint, 11, to get 55. You do the same going all the way down that column, and I got 2055.5. So you check if you can get that by working out those values. This column here, you would square the midpoint first, which is 121, times it by 5, and the first entry here would be 605. You try doing that for that column and see if you get the same total as me. 3655500.25. So you may want to pause the video at that point and see if you can get those two totals. The next step is to substitute those into the formula. So the mean is the sum of FM over N. So it's 2055.5, and I think in this question there were 120 students. So an estimate of the mean would be 17.1, which is the same actually as the median. The standard deviation would be, again, always write out the formula that you're using and show where you're substituting the values. So we would have that large total from the top, 36500.25, divided by the number of values, which is 120, take away, I'm going to use the full mean, and if you work that out using your calculator, you should hopefully get 3.28 to 3 significant figures. So lots of work there, but 6 marks, and actually 6 relatively easy marks if you've learnt your formulae. The next step asks us to measure the skewness. Now you will have been reading through your notes and you will know that there are some rules relating to skewness, and they've given one of them here for us. You have to work out 3 times the mean. Now I'm going to use the exact mean here, which was 2055.5 over 120. I'm going to subtract the median. Now, when I go back and work out the exact value again, it actually works out to be quite a long decimal. I rounded that off. So that's the top line. Use the exact values there. Don't use rounded values or you won't get the correct answer. On the bottom, we put the standard deviation. Again, make sure you use the full answer off your calculator, not the rounded one. And when you work that out, it comes out to be very, very small, minus 0.00798. So it says evaluate this coefficient and comment on the skewness of the data. So I would say the skewness is approximately 0, so no skew. We would want this number to be a lot bigger for us to be able to say it was a negative skew. It's so close to 0 that it's not really appropriate to say that that's a negative skew. Greg now suggests that a normal distribution is a suitable model for the foot lengths of 10-year-old children. Use the value in part C to comment on Greg's suggestion, giving a reason for your answer. Well, you may not have come across the normal distribution yet, but the normal distribution is a symmetrical, sometimes called bell-shaped curve. The important thing about this is that the normal distribution is symmetrical, so no skew. That's the crucial thing. In part C, we had almost 0 skew. So we would think, therefore, the normal distribution seems suitable. Another thing that made me think the normal distribution might be suitable, if we just go back up the page a little bit, is when we got the median and the mean working out to be the same value. When you study the normal distribution later, the mean, median and mode are all slap bang in the middle. And in this case, the median and the mode were both 17.1, so that would lead me to think that perhaps a normal distribution was going to be suitable in this case as well.